Welcome all. My name is Dr. Mahender, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. So today my topic is synthesis routes of nanomaterials. Okay, last class we have discussed about what are the methods to synthesize the nanomaterials. Today, mainly I will focus on synthesis of sol gel method. Okay, so my topic is synthesis routes of nanomaterials. Okay, so first I will give introduction about nanomaterials. So then we'll start about the sol gel method. Okay, the meaning of what nano is. A nanos which indicates a person of very low height or a very small object, that is a trough. So nano simply will say nano means that the particle which is in a very small size. So consider that it is an international system of units. The prefix nano is used to indicate the part of a unit. Okay, so because of that one, so we are using this nano as a prefix as one of the unit for the nanomaterials. Okay, for instance, a nanometer is a billionth of meter or a millionth of millimeter. A nanoliter is a billionth of a liter or a millionth of a millimeter, and a nano is billionth of a Kelvin. So this is about the nanomaterial unit. So why we are considered what is a nano? So nano means I will say this is a nanoparticles. So nanoparticle means the particle which contains one of the particles which contains a size below 100 nanometers. Then we call that is a nanoparticles. Okay, size which refers to the length scale from 1 to 100 nanometers in the fundamental defining attribute of all nanoparticles in which material has at least nanoscale dimension. Then we can call it is a nanoparticle. Nanomaterials are substances that are between 1 and 100 nanometers in size, at least one of the three dimensions. We have discussed in the last class about the one-dimensional nanoparticle, two-dimensional nanoparticles, and three-dimensional nanoparticles. In any one-dimensional particle which contains in a nano size, then we call it is a nanoparticle. The field of study known as a nanotechnology includes the synthesis, engineering, and application of nanomaterials. Okay. Due to innovative and introducing applications of nanomaterials for the next industrial generation, nanotechnology has attracted a lot of interest over time. So from the past to now, the nanotechnology has been very interested or very attracted. So because of their beauty of their properties when compared to the bulk materials. Okay, agriculture. The applications of nanomaterials will be in agriculture, biomedicine, electronics, energy pollution abatement, food engineering, transportation, telecommunication, cosmetics, cosmetic coatings, materials, and mechanical engineerings, and just a few of the industrial and use of nanometers. So, a wide variety of applications of nanomaterials are there. So that we have discussed agriculture, biomedicine, electronics, pollution, abandoned food engineering, transport, telecommunication. So I will use. There are various applications of the nanomaterials. Okay, so nanomaterials is nothing but it is not a different material, but the same material. If you are bringing down to the nano size, entirely the physical properties, chemical properties of that material is entirely different from the bulk material. Bulk material means the material which is at a normal size. Nanomaterial means the material which is in the dimension of 100 nanometers, that we call as nanoparticles or the nanomaterials. Okay, so I think this is understood. Bulk material means normal material. Nanomaterial means the size of the particles will be below the 100 nanometers. Okay, so in general, nanomaterials are synthesized using a variety of methods. So nanomaterials can be synthesized by a variety of methods. So which are categorized into two main categories. So nanomaterials can be synthesized in different ways, but broadly it has been categorized into two methods: bottom up and top down method. So what is this bottom up? Bottom up and top down. Bottom up approach is a method when bottom up approach is a method when we are synthesizing the nanomaterials itself, we are converting into nano size. Whereas top down means already the materials has been synthesized, or already the materials are present. That materials we are bringing down to the nano size. That is called top down method. Okay, bottom up means when the suppose example, suppose if you want to synthesize titanium nanomaterials, right? So I will give example. What is a bottom up and what is a top down method? Okay, what is bottom up and what is a top down? So suppose example, if we want to synthesize the titanium nanomaterial, if you want to synthesize the titanium nanomaterial, so first what we require in first I will discuss about the bottom. So in the bottom up, what we'll take? We'll take the titanium source. One will take the titanium source. Suppose titanium source is titanium tetrachloride. So from the titanium tetrachloride, we'll bring the titanium metal, right? So in the bottom up approach, when we are taking the source is here. What is the source here? Titanium tetrachloride. What is our metal? Titanium metal. So when we are synthesizing the titanium metal itself, we give such a conditions. Will give such a conditions that the titanium chloride can be converted into titanium metal. That converted metal will be in the form of nanomaterial. So when the material is synthesizing itself, we are converting that into nanoform. That is called bottom up approach. Why it is called given bottom up approach? Because from the bottom level, when the particle or when the material are synthesizing, from that size, from that stage only, we are trying to convert the metal in nanoform. So that's why it is called bottom up approach, or we are following the process from the starting level to the end of the material which has been produced. So that's why it is called as bottom up approach. So now we can see what is a top down method. So what is a top down method means? This method, the material has been synthesized, or the material will take, suppose if you want to synthesize the titanium nanomaterial, so we'll take titanium tetrachloride as a source, and we synthesize titanium metal. We synthesize the titanium metal. So this titanium metal will be converted into titanium nanometal. Titanium nanometal. So now in the top down method, already the will synthesize the titanium metal, then we'll convert into the titanium nanomaterials. So that's why it is called top down method. So why it is called as a top down method? We'll take the bulk material and we'll convert that bulk material into nanoform. Means that's why it is called top down. Why it is a top down means we are bringing down the bulk material size of the material from top to the bottom, top to the down. So that's why it is called as top down method. So I hope everybody understand why the name has been given as a top down and the bottom up approach. So now we'll see, right? So the top down method, also known as a destructive method. The top-down method is also called as destructive method. Top-down method, why it is called a top-down method is called destructive? Because we are bringing down and we are destructing the material to the small size. So that's why it is called as a destructive method. Okay, decomposes bulk materials into small materials, which then transform into nanomaterials. First, we'll destruct. We'll destruct the higher size to a small size. So that's why it is called as a destructive method, and it can convert into small size, that is called nanoform, then transform into nanomaterials. So lithography, mechanical milling or ball milling, laser ablation, sputtering, electronic explosion, etc. Electronic explosion, arc discharge, and thermal decomposition are examples of top-down method. So these are the best examples of top-down approach. So what are that one? First one is lithography, mechanical milling or ball milling, laser ablation, sputtering electronic explosion, arc discharge, and thermal decomposition are examples of top-down method. Okay. So next, bottom up. So what are the bottom? The bottom up method is also known as constructive. So then when we go for what is a bottom up approach? Bottom up approach is nothing but constructive. So constructive means when we are synthesizing itself, we are converting into the nanomaterials. So that's why it is called as constructive. So we'll see the definition. The bottom up method, also known as a constructive method, involves the building of materials from atoms to the clusters to nanoparticles. First will atoms, clusters to the nanoparticles. So the examples of this one is CVD. CVD is a chemical vapor deposition, and sol gel method, spinning pyrolysis, and biological synthesis are examples of the bottom up methods. Right. So these are the examples of bottom up. And in this one, so today I'm going to explain what is a sol gel method. So we'll see what is a sol gel method, right? Sol gel method is one of the bottom up approach. Okay, it is a process by which a suitable chemical solution serves as a precursor. Precursor means the source of the material or the starting material. Metal oxide and chlorides are common sol gel method precursors. So generally, the source will be taken as metal oxide, or the metal will be in the chloride form, will be taken as a precursor. Metal oxides and chlorides are the most sol gel precursors. Metal oxides and the chlorides. Suppose if you want to synthesize the titanium, we'll take as a titanium tetrachloride as a source. And suppose if you want to synthesize iron, so we'll take the iron oxide as a source or precursor. Okay, so these are the table chart, so which can explain the synthesis routes, right? So synthesis methods of nanomaterials. So first, left side we can see this is a bottom up approach. Bottom up approach again will be classified into chemical method and biological method. Okay, so chemical method means we'll use some reagents, and chemical method means we'll use some biodegradable reagents so that it can be synthesized. So if you see the chemical methods, so sol gel method, spinning method, soft and hot templating method, pyrolysis method, chemical vapor deposition method, salvothermal and hydrothermal method, and reverse Miscellaneous method. So next one, this bottom up approach are again classified into two types. So that means chemical method and biological or green method. So biological method is also called as a green method. So we will not use any chemical reductants, or if we use a chemical reductants, so it is also called as a green synthesis. So nowadays this biological method is also called as a green synthesis. So this green synthesis can be microorganisms. If we use the microorganisms as a reductants to synthesize the nanomaterials, it is called as a microorganisms. If we use a plant extract, and if we use some bacteria, that is called a biological templates. Okay, again these microorganisms are fungi, yeast bacteria. If you use the fungi, yeast or bacteria as a reagents to convert that into nanoparticles, so this is called biological method. And next one is plant pot. Plant pot, if we will take the root pot as a reagent, or the leaves, or will take the flowers as extracts, or it will use as a reductants, then it is called as a plant pot. Then biological tablets. Okay, so these are about these are the various methods of the bottom up method. So then we come down to this top down method: physical and chemical method, thermal decomposition and mechanical milling method, laser ablation method, sputtering method, the arc discharge method, and the nano lithography method. So these are called the top-down method. So we have also discussed before, this top-down method means already the material will be there. We'll convert that material into the nanomaterials. But where is the bottom-up approach? By the synthesis itself. When we are creating or when we are synthesizing itself, we try to convert the material into nanomaterials. So these are the broadly divided into two parts. So today we'll see what is a sol gel method. Okay, in that one, very important synthesis method of nanomaterials and very easy or sol gel method. It is a process by which a suitable chemical solution serves as a precursor. Suitable chemical solution serves as a precursor material. Metal oxides and the chlorides are common sol gel method precursors. So generally, the source will be taken in the form of oxide or in the form of chlorides. Generally, it will be taken in the form of chlorides or it may be in the metal oxides. Will be the precursors. Metal oxides and chlorides are the most common sol gel precursors. Sol gel precursor is nothing but the starting material of the nanomaterial. Starting material for the synthesis of the nanomaterial. Then we'll see what is the sol gel method. So sol gel process is a more chemical method, or this method is also called as wet chemical method. So because it will be done in the wet laboratory or it will be done in the solution phase, so that's why it is also called as a wet chemical method. Sol gel, other name of the sol gel method is wet chemical method. For the sol gel process is a more chemical method for the synthesis of various nanostructures, especially metal oxide nanoparticles. So especially metal oxide nanoparticles preferably synthesized in this method. Okay, the molecular precursor usually metal alkoxide. Molecular precursor generally alkoxide. Suppose if you want to synthesize the titanium dioxide, so we can take titanium propoxide. Suppose if you want to nickel, we can also take nickel isopropoxide. Like that, which one will be there? The precursor should be in alkoxide form. First, it has to be dissolved in water. So the precursor, first what we have to do in this method is it should be dissolved in a water or it should be dissolved in a alcohol. That will be based upon the dissolution capacity of the precursor material. Okay, we have to take the precursor and we have to dissolve in the water or the any solvent. In this method, initially what they will do, they will take the precursor and they will dissolve and they will make the solution into gel form, and then they will go for filtration and drying techniques and calcination also. Then a typical sol gel process using alkoxide precursors involves the following. So today I will discuss about if we take the alkoxides as a precursor, what are the steps involved in that. Okay, first one, formation of a stable source. Formation of a stable source means first we'll dissolve the precursor in the material, then casting or the shape formation, then will form gelatin of the solution, means the solution will be formed in the form of gel, and then aging of the gel. Aging of the gel means it will be kept for some days so that it will be in the form of gel. Okay, drying of the gel, then calcination. Calcination means heating upon a temperature, then sintering if it is necessary. That will be depend upon the nature of the particle. Sintering will be, if it's necessary, it will be sintering. So first one, formation of Formation of stable solution means first it will be dissolved, then it will be casting. Depending upon the casting, if it is required, casting is nothing but to give a good shape to the molecule. Then gelatin of the solution. So we'll make that solution very gelatin, so that by adding acids or the bases, so we'll make it a gelatin solution. Then aging of the solution. Aging of the solution means keeping without disturbing for 2 to 3 days. Then drying of the drying of the gel. Then we'll dry it. Then calcination means we'll heat the temperature depending upon the nature of the metal. Then sintering if it is necessary. Okay, for synthesis of metal oxide nanoparticles through sol gel method, the process mainly involves two key processes. Process mainly involves the two key processes: hydrolysis and condensation. So to synthesize the metal oxides, hydrolysis and condensation plays a prominent role. For aqueous sol gel process, the conversion of the precursor solution into metal oxide is via inorganic polymerization reaction induced by water. Aqueous solutions, first it can be a precursor can be converted into inorganic polymerization, then polymerization reaction induced by the. So the sol gel method involves two main reactions. The sol gel method involves two main reactions. First one, hydrolysis of precursor in the acidic or basic mediums, polycondensation of the hydrolyzed product. Polycondensation of the hydrolyzed product. In this way, the polymeric network is formed in which nanoparticles can be retained. Okay, so this is a flowchart diagram. So how it can be here, the solution, it can be formed into the gel form, and drying, then crush or ball mill, and it can be porous particles. So in this one, suppose silicon source or the water catalyst can be used in this one. Then granules will be formed, or emulsion, in the presence of emulsion also we can use. So depending upon that one, so we can freeze or dry granules. So spherical or porous are the particles. So that will depend upon which type of one we have to synthesize. So first one, we have to prepare this solution, then we have to form the gel form, then dry, then it is a dry or granules or spherical particles. So depending upon the uh, requirement, so we can. So next one, the materials obtained from the sol gel method are used in what applications. So what are the applications? So what are the applications means where the nanoparticles will be used? Even though the material can be synthesized from the sol gel method or the laser ablation method, the applications will be same. But generally, I will explain some applications used in various optical, electronic, energy, surface engineering, biosensors, pharmaceutical separation techniques such as chromatography. Okay, so uh, this is application. So applications is nothing but whatever the nanoparticle will be there, which method it can be synthesized, depending upon that we can utilize. And these are the applications. So these are the some of the references. So mainly most of the reference I have taken essentials of nanomaterials by N Kumar, and I'll take introduction to nanoscience and nanomaterials. So Dinesh C Agarwal, Indian Institute, page 572, and introduction to nanomaterials and nanoscience by Asim K Das, CBS Publications and Distributed Private Limited. So mainly I have taken these three references for this lecture. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.